Mm. Good morning, ladies and gentlemen. All participants of the Training on Mangrove Health Index. Nice to meet you today. I am Suyaroso, representing from uh, Marine Geospatial Laboratory from Research Center for Oceanography Indonesia Institute of Sciences. Will help you to do with connecting in the remote sensing to the mangrove area. As we know that the important reason is why remote sensing can help in the mangrove research. As we know that mangrove have chlorophyll content, the highest chlorophyll content if we compare with another vegetation. So the mangrove uh, easily detect that from the image. Look at this figure, this one. Don't see the text, this one, but the background of this one. This is a mangrove. As we know that the visible light from that coming from the sun when hit to the mangrove will the greater part will reflected again into the sensor or camera of satellite. But on the infrared light, when hit the mangrove, a greater part of the light will be absorbed in the mangrove. They depend on the mangrove condition. When this mangrove is crowded like that, the greater part will be absorbed. Maybe a small part will be reflected again to the camera of satellite. But when the mangrove is rare or not crowded like that, you can see this is water, this is salts. When infrared light coming from the sun hit this one or this is part, the greater part will be reflected again to the camera of satellite. Uh, Now I have a image that I get from the U.S. Geological Survey. Uh, I'm interested in the mangrove of Cilacap area. If you see this figure, this is Sumatra Island, Jawa Island, Kalimantan Island, Sulawesi. This is Jawa. This is Cilacap area. When I zoom it, this is located here because Cilacap area is a interesting mangrove forest. Mangrove forest in Cilacap may be the widest mangrove forest in Java area, close with Jakarta. Maybe from Jakarta, if we use travel or by train, we need only 6 hours. And when you arrive here, you can use with a small boat from the fishermen to around through the canals of the Segaranaan. you can see an interesting forest of mangrove. This is located here, so not so far from Jakarta. Okay, now I try to process the data that I get. This is a bundle of Lancet uh, recorded on 28 August. So maybe last 2 years. So before we processed it, we extract because it is in the zip file. You can use the extract file here. Uh, Wait a moment for this time, for this processing. Okay. As you see in the file, it contains several files here. Band 1, band 2, band 3, band 4, band 5, band 6, band 7. This is an important band that will be used. Now back to the our program. This session, we will help you to image radiometric correction, image stacking, and image resizing. Software used as a QGIS. Okay, now we start with QGIS. Okay, now we open all this file, this one. This icon we use pre-processing. We open this icon. It will appear figure like one. This is correction form for Lancet. This one. This is for Sentinel. Sentinel 3. This is for Aster imageries. This is modis. We select for Lancet correction. Okay. And now we fill this sum of question, this one, where directory containing Lancet band, we open it. So I put it in the training directory. Oh, this one. Select folder. All file will automatically enter these columns, and we must fill about this brightness temperature. Okay, we click it. DOS, it means dark object subtraction. So we will correct about the darkest area because as we know that the darkest object, reflectant of the dark object, it should be zero because due to in the particle of the atmosphere much particle, so sometimes it's not good if we don't use this one. Use this one. Uh, for this one, perform unsharpening lens set. It means that originally lens set record on the ground area with a resolution of 30 meters wide and 30 meters long. So we call it that the resolution of lens set in 1 pixel it's 30 meters. So we using with pen 8. Pen 8 is a single pen, but it have a 15-meter resolution. So we are using through pen 8. All pen will follow with a small resolution that is a 15-meter resolution. So we click this one. So and then select MTL file. MTL file is this one. MTL is a metadata. Metadata file, it means data to describe when set image already taken and what time, when position of the sun, and all coordinate in the image and others. So we open it. There's a training directory already filled, MTL file already filled, all already, and then we just run it. Yeah. And then the last is where the data will be put it. Select the folder. Okay. When they start, it is a blur like that. It means we are waiting for processing. This processing can be consume time of 3 minutes and can also be 5 minutes, depend on your computer. We advise you, or if you are working with a UC software, minimally in your PC or your laptop, minimally need 8 GB of random access memory, because smaller than 8, this is a lot of problem. Okay, we are waiting this processing. Ah, in the screen, the text become appear again. It means that the process already finished. Now we are looking for the result. Ah, in the result, this is a original file from bundle and set, and this is uh, the file below is the result of the process. It means that pan. It means pan shortening. Every file in each pen already convert that originally centimeter resolution. It become uh, 15 meters as you saw when original file. This is only if we look at the bento 100 mega, and the result of processing become 5 times 500 mega. So from the result we will stack file compose. It is single file, single file, single file, all single file. So we will make a one file that consists of 6 pen here. Okay, let's we try the resolution. You can get out all file first. You can with right click and remove a layer. Okay, yes, already removed. You can back to SGP. SGP doc. This is a left icon. This one you can click. Uh, automatically all file already processed and radiometric correction will appear. It's called. Uh, but we need all. We just only pen 2, pen 3, pen 4, pen 5, pen 6, and pen 7. The other it should be get out. This one only. We can drop it. Okay. Yes. Look. Oh, this should be refreshed. Okay. Now we put it. Pen 2, pen 3, pen 4, pen 5, pen 6, pen 7. Open. Okay. Yeah. And now we will stack. We look at this layer, icon layer here, layer, look, okay. You will show for pen 2, pen 3, pen 4, pen 5, pen 6, and pen 7. So the next step is you click raster icon here. Look, you direct to miscellaneous. Click merge. Try once more. After all file that you need, that you see will be stacked into one file, correct first pen 2, pen 3, pen 4, pen 5, pen 6. Okay, and then you click raster here to miscellaneous, and you click merge. Merge it means it's bound into one file or join together in one file. Merge. Okay, this is a input layer still 0 because we don't fill it yet. So we click here input layer. Now every band will appear here. Start from band 2, band 3, band 4, band 5, band 6, band 7. Okay, and then we should be select all. Yes. We correct carefully. Okay, already all. Pen 2, pen 3, pen 4, pen 5, pen 6, pen 7. Okay. After select all, we click it OK. So become fill 6 elements selected. Then we click that all here. We use that float 32. It is just a mathematical number. Merge. Don't forget to save the file. Okay, here shift to file. We use the directory of before. Training number. Don't forget we give a name. Stack. Image. Okay. Shift. We check carefully again. Already select 6 element. About file processing will also already filled. Okay, and then running. Yeah, we are waiting again for running this stacking file. Oh, merge, finish. Okay. We close this one. This is the result for one file that consists of 6 pen smurfs. Okay, but our file is a stack file. Okay, we can change this one. All layer here you can remove it. Okay, you can select this one, or you can select it. Right click the mouse, remove layer. Okay, switching with our file. Now use add raster file here. Raster file, you can click, change the training directory. Okay, our file is stack. Here below, you can open it, and then add, and then close. This is a stack file that we need. You can click with right mouse and then left mouse. You click in the left mouse and then click with the right click and click for properties. You can show the symbology. As you show, when we stack file, we started with pen 2, pen 3, pen 4, pen 5, pen 6, and pen 7. After we stack it, all pen will be start with the number 1. This is pen 1, pen 2, pen 3. We can change with the composite of the lancet with the infrared band or near infrared band. We check it. Near infrared band is band 4. Click here, and green band we use band 5 here, and we will combine with the band 3 here, and then apply. The image will show like that. Okay, and we zoom it. This is a Cilacap area that we will need. And now, as I told you previously, our session is image radiometric correction. It's already done. Image stacking just now. And now, the last one is image resizing. I told you before that if the sunlight hit to the mangrove, a greater part of light will be absorbed due to chlorophyll content in the mangrove. And now we will see in the image what it look like. Uh, you can see this mangrove forest at Segara Anakan because this is mangrove area. This is absorb a greater part of infrared band and short wave infrared band. It means band 6 and band 7. If in the file, in this file, it's we use band 4, band 5, and band 3. Okay. Now, because if you do with a wider image like that, it's need a long time. So we just focus on our area here and we crop it. Yeah, small part of this image. So we zoom it. Okay. This icon will I switch it off. Okay. I just need this area only. So how to add, how to crop it? We go to raster. Please look carefully. This is a clip raster. So we go to raster and then to extraction. I will clip the raster. If I use this one, I will do fast what I like. But if we use this clip raster by mask layer, we must prepare like file to border this area. If we choose this contour, we should prepare a contour map. So which better I use? I will use raster by extend. Click here. The file that we will resize is a stack image file. Okay. And the second row, clipping extend by, this is a coordinate. If we don't have a coordinate, we can do it three option. Use canvas extend, select extend on canvas, or use layer extend. We don't have a layer extend, but the option is only two. They use canvas extend or select extend by canvas. Okay, we will try for this one. Use canvas extend. True. Ah, canvas extend means the area will crop as what you see in the screen, just like that. If you select option, select extend on canvas, will disappear, but now the cursor will change with plus mark, so you can boundary by what you like. So I move it here, and you can make a boundary from here, like that. It's up to you, but we better we close it. And now I repeat it again. It makes smaller again. Okay. Here. And now we select raster, extraction, clip raster by extend. Okay. And now I like this one. Extend on canvas. Okay. I will select that I like. This is enough. Okay. And now we fill where the clip file will be saved. So we fill it. Save to file. Okay. Crop. I give the name as a crop of stack image, and then save. Okay. And then run. Okay. Yeah. Raster extend already finished. Okay. We close it. Okay. Clip extend. We can move it out, remove layer, all, and then we fill it with the new one. This one, add raster layer. Okay. Crop stack image. This is our file that we need. Okay. Add, close. This file is like that. And now we will show our composite. You can click crop stack file. You can click right mouse and then click properties. Okay. we composite always with uh, near infrared band for band call, and green band we fill with SWIR 1 short wave infrared 1 band 5, and the other is visible light band 3, and then click apply. And now we just work for the next step is with this file crop stack image. Back to our session, we done image radiometric correction, image stacking, and image resizing. Okay, this is the result of all session that are already done. Okay, I hope you able to do for this job. If you find a problem, you can contact us. I always help you until you able to do this. Okay, nice to meet you. Say goodbye. Thank you.